Lesson 6, HTTP and DNS. At the conclusion of this lesson, you should be able to describe how HTTP is used for sharing the files and pages that make up the World Wide Web. You should be able to describe how the Domain Name Service, or DNS, helps the Internet scale by allowing devices to find the IP addresses associated with the domain name. You should also be able to explain how different layers of protocols on the Internet build upon and rely on one another. Today, we're going to finish the study of layers of the Internet and learn about two final protocols. Let's just hop right in. Now, in the times when we are in person, as you walk into the room, I will have handed each of you a slip of paper with your IP address. We know that in order to communicate on the Internet, you need to know the IP address of the other computer. So far, we've let you ask one another addresses when communicating on the Internet simulator, but this can be tricky. And by we, I mean myself and code.org. So, as a warm-up, again, as you entered the classroom, I gave you a slip of paper with your IP address. This is if we're live. Since we're not live, we can't do this activity. There's just no way to simulate it. What the activity entailed was creating a list in your notes of everyone in your class's IP address. The only rules is that as you walked around the room, you could share information with your classmates, but you could only share or talk with one classmate at a time. So you couldn't gather in a big group and one person shout out what their IP address was and give it to everybody. You literally had to be one-on-one. Now, as you did this, I would walk around and I would, as you walked around from one person to the next, I would come by and I would swap out your IP address. I would take what you had and give you a new one. And at the conclusion of the activity, you would need to think about, I was switching you and your classmates' IP addresses. Why? If IP addresses can change, is there a better way for everyone to know everyone else's IP address? And these are things that you needed to think about after participating in the activity. Now, the takeaways from this form of activity were that devices are joining and leaving the Internet all the time. IP addresses do not stay constant. If you go to a coffee shop or restart your browser, your device might be assigned a new IP address. And if IP addresses are switching, it's very hard for each computer to keep an accurate list. It would make more sense if there were one system that kept track of all the information, and then you could simply refer to that. Now, if we want the Internet to scale up to billions of devices, not just a handful, but billions, then we need a better way to figure out one another's IP addresses. As we watch the following video, you're going to take notes in your journal on how does the DNS, or Domain Name Server, solve the problem of translating domain names, like example.com, into IP addresses, and how does the DNS help the Internet scale. So at this point, when you're watching this video to make up the lesson because you weren't in class or to just review, you need to go and watch the first lesson or the first video in the list of videos for this lesson on Canvas, okay? Or you could do it from code.org, either one. It is called The Internet, IP Addresses and DNS. And again, within your journal or your notes, you want to note how does the DNS, or Domain Name Server, solve the problem of translating domain names, like example.com, into IP addresses? And how does the DNS help the Internet scale? Both of those are important questions and will be seen again in quizzes, tests, and the AP exam. So at this point, if you want to pause this video and go watch this one, that's great. I can't put a video in a video. It doesn't work very well. So I would suggest pausing, go look up the Internet IP addresses and DNS and watch that, and then come back. Okay, if you're back, okay, we're going to look at and discuss the prompts of what I asked you, okay? In class, we would have a discussion. I would ask what everybody got from the video. Since this is not synchronous, it's asynchronous, you're doing this by yourself, I'm going to go over the main takeaways from the video. And that should have been that the DNS is a network of servers that track the IP addresses of different domain names like example.com. When you visit a website, you first ask the DNS for the IP address of the domain you want to visit. The first server to ask may have to ask other servers for this information. This system allows billions of devices to get added to the network without putting pressure on any one computer or server to know all of the IP addresses in the world. Now, at this point, we're going to go and use the final version of the Internet Simulator on code.org. This time, we won't cheat and ask out loud for one another's IP addresses. So what you need to do is go to Unit 2, Lesson 6, and then go to Level 2 on Code Studio. So again, this is Unit 2, Lesson 6, Level 2, the Internet Simulator. Pause the video while you do this. All right, now you're there. What I want you to do is log into this version of the Internet Simulator. Now you need to have somebody else do this with you. So again, if you are asynchronous, if you can find a buddy or two from the class that you could work with on this, that would be great. Otherwise, you can just pop through this video. Okay, so in class, there was no talking at all, not even to get your partner's IP address. Then you ask the DNS for the IP addresses of a user by sending a get username. So get is capital G, capital E, capital T, and then the person's username. You're going to use the IP address you get back to communicate with at least 2 friends. So again, if you're doing this by yourself, you can reach out to a couple of friends in the class. Maybe they'll do it with you. When you chat with them over the network, you want to talk about, in your ideal world, what time would school start, or what would you eat for your perfect meal? Again, these are just suggestions about what you could talk about for a few minutes. And this is to get used to this new Internet Simulator. It's going to look like this. Okay? And this activity took about 6 minutes. Okay, when you were done with it, you could see that on the Internet Simulator, thanks to DNS, we can talk to other people even if we don't know their IP addresses. Additionally, this system is built entirely on all the other layers below it. When you talk to the DNS, you're still sending information over the network. You still need to know the IP address of a DNS server, and you still send messages that get turned into packets routed using UDP, or occasionally called TCP and IP. This is what it looks like above. To, from, one packet. So you're still building on everything that we've learned so far in this unit. Now, you're going to watch another video on HTTP protocol. What problem is HTTP solving? You need to note that. What is a GET request, and what are you requesting? How does HTTP rely on the other layers of the internet? What problem is HTTP solving, and what do certificate authorities do, and why are they necessary? Yeah, this is repeated twice. What can I say? All right, so go ahead. Now at this point, you're going to pause the video, and you're going to go and watch the internet, HTTP, and HTML. Again, there's a link for this from the Canvas page in Unit 2. I think it's actually Lesson 6. Don't know why that has Lesson 5 up there, but Unit 2, Lesson 6. And then you're going to answer these questions. You could also get to this from Unit 2, Lesson 6 on code.org. So again, at this point, you can pause this video and go watch the other one and then come back. You back? Great. Let's review these questions. What problem does HTTP solve? How does it work? How does it rely on the other layers of the internet? Well, here are the most important points for you to take away from this video. When you visit a website, you're actually getting sent a file by a server. HTTP is solving the problem of how to ask for that file. That's what HTTP does. It figures out how to ask for the file. Your computer and that server communicate using a protocol called HTTP. It's an agreed upon set or format of ways, rules to ask for and receive information. HTTP is plain text, so it literally includes the ASCII word GET, and the file name requested. All of your communications are being sent over the internet, so these requests are being sent inside TCP/IP packets and over the physical wires of the internet. There are other secure ways of sending information online because using HTTP, all our information would otherwise be sent as plain text. Certificate authorities ensure that when you start a secure connection, you're talking to the website you think you're talking to. So a good thing to always look for when you're on the web is to make sure you've got HTTP : and then something. That makes sure that you are where you think you are. Otherwise, you could be on a spoof website, and that's not good. Now, in wrapping up this lesson, some of the key takeaways: scalability, the capacity for the system to change in size and scale to meet new demands. That's what scalability is. The World Wide Web is a system of linked pages, programs, and files. That's all. The Domain Name Service is the system responsible for translating domain names, like example.com, into IP addresses. Hypertext Transfer Protocol, or HTTP, is a protocol for computers to request and share the pages that make up the World Wide Web on the internet. The World Wide Web is different from the internet. The World Wide Web are files, web pages, and media. The internet is the actual network that we use to access those files. The DNS is an important system in helping the internet to scale. You will now need to download or print and review the layers of the internet document. This is yours to use to study for the test, to review, and understand. When you download it, again, you can get this from code.org or from the Canvas. Layers of the internet, it goes through, it talks about the protocol, what problem it solves, and how it works. You should be able to answer both of these questions about any of the protocols or layers listed. Okay, and again, this is just the top part of it, so you know what it looks like. But you need to download it, save it on your computer so you can refer to it, soft copy, print it so you've got hard copy. Whatever works best for you. Now, using that document, you should be able to explain how each of the different layers is involved when you go to a link like code.org. So if I wanted you to explain going to code.org, using the layers of the internet, you should be able to explain that. As a review, your response should look something like this. When you type in code.org, your browser will connect to the DNS to find code.org's IP address. Once you receive that address, you will send an HTTP GET request to code.org to send you its homepage. Code.org's server will respond with the HTML code that makes up its web page. All of the communications above happen on the internet, which means TCP or UDP will break the message into packets and then send them. If TCP is used, error checking will occur. IP will route the packets back and forth between your computer and the server. All of this information is sent over the physical wires, cable, Wi-Fi networks, and routers that make up the physical network of the internet. Okay, remember TCP is a slower way, but it has error checking. UDP is what you do when it's fast. Remember our whole moving books out of the library scenario? Difference between TCP and UDP. Now, at this point, you know a lot more about the internet than the average person. Next, we're going to turn our attention to thinking through how we can use this knowledge to make good decisions about the internet's impact on our everyday lives.